All right, welcome to Pre-Calculus. This is section 5.3. We are going to be continuing with solving our equations. The top of the page, you should see Roman numeral 3. It says functions involving multiple angles. So again, this is still section 5.3, and we are going to be working on solving. All right, let's see what we've got. Example 6a says, solve and check with your calculator. All right, well, we still isolate and completely solve our equation. So this is going to be sine of 2t, 2 sine 2t equals negative 1, subtract 1, and then divide by 2. So sine of 2t equals negative 1/2. What we want to know is, when is the sine of the angle negative 1/2? Well, the angle is 2t though, so we're thinking of this. Sine inverse of negative 1/2. When does that equal 2t? Well, the sine is negative 1/2. We got to look at those values. Sine's negative in quadrant 3 and 4. Okay, so we're looking at these two reference angles. So our first reference angle would happen at 7/6 pi. So 2t equals 7/6 pi. And not only is 7/6 pi, but since we're not limiting our window here, then we add 2 pi to it because that takes us all the way around again. So 2 pi n. Remember, we do that in any case that you're not restricting the domain, or you're not restricting the window at which you're finding solutions to. If 2t equals 7/6 pi plus 2 pi n, then t would equal 7/12 pi plus pi n. All right, so there's half of our solutions. Let's go ahead and look at the other set. So 2t would equal, if I go to my other set of solutions, they are going to occur all the way around to 11/6 pi. So we have 11/6 pi plus 2 pi n, again, for getting that second and third revolution. So then t would have to equal 11/12 pi plus pi n after dividing by 2. All right, so my solutions there are t equals 7/12 pi plus pi n, and t equals 11/12 pi plus pi n. So anytime you have multiple angles, that's kind of the route you're going to take. You set your multiple angle, that would be right here, equal to the solutions that you're getting. And you just got to solve. All right, my next example, cotangent of x over 2 plus 1 equals 0. So I guess the first thing I'm going to do is I'm going to subtract the 1. So cotangent of x over 2 equals negative 1. So when does cotangent of the angle equal negative 1? It would be the same time that tangent of the angle also equals 1 over negative 1, which is negative 1. So this occurs, this happens, x over 2 would be equal to negative 1 at, in quadrant 2, tangent's negative, so 3/4 pi. And then let's look at what we have here. So my answer would be at 3/4 pi here. And I would also have another one at 7/4 pi. So if I find the first solution here to be at 3/4 pi, I can find all other solutions as I go around by adding another pi n to it and adding another pi n. And we would keep getting those answers. So plus pi n. All right, that takes care of all of them. So now let's solve for x. So x would equal, multiply the other side by 2. That's going to be 6/4 or 3/2 pi plus 2 pi n, multiplying by 2. All right, those are your solutions. Example 6c, we want to find out what the x values that would make this true. So it's already solved for the sine of 4x, so we need to figure out 4x would equal, when is the sine the root 2 over 2? First of all, sine is positive up here in quadrant 1, so this would be my pi over 4 angle, that's the sine. It would also be at quadrant 2 here, 3/4 pi. So you set 4x equal to, let's do pi over 4 first, and we'd have to add 2 pi n to it. Divide by 4, so it would be pi over 16 equals pi over 2n, or plus pi over 2n, not equals, plus. All right, let's see what happens when I use my 3/4 pi. So 4x equals 3/4 pi, and again, keep going around, so plus 2 pi n. Divide by 4, so x would equal 3/16 pi, plus 2 divided by 4 is half, so pi over 2n. So those are all of the solutions. Again, how to solve a multiple angle. And the first three examples here that we've talked about, our solutions come from the fact that we keep going around all rotations. We don't restrict it just to the first rotation. All right, example 7, solve the multiple angle equation for the interval from 0 to 2 pi. So now we are restricting our interval. This is what this multiple angle means. It means that there are 3 tangents. This is what it means. There's 3 tangent curves within the 2 pi. There's 3 tangent curves within 2 pi. All right, well, what I'm going to do is I'm going to go ahead and find my first set of solutions. We've got tangent of 3x. If you take the square root of both sides, you get plus and minus the square root of 3. So here's what we know. We know that tangent would equal the positive square root of 3 here at pi over 6. Excuse me, pi over 3. And then the second time that it would equal, this is negative here, so that's at 2/3 pi. And then the third time would be here at 4/3 pi. And then one more time at 5/3 pi. All right, but that's just giving us the values when they're equal to 3x. So we've got 3x would equal pi over 3, and if that's the case, then x would equal pi over 9. We've got 3x would equal 2/3 pi, and if that's the case, then x would also equal 2/9 pi. And 3x would equal 4/3 pi, and that would give us 4/9 pi. And I give you one more here, and this is just going to be the first of 3 tangents for the angles, because since it's going around 3 times. 3x equals 5/3 pi, which concludes that we have x to be equal to 5/9 pi. All right, you can see that 5/9 pi is still a lot smaller than the interval that we're dealing with here. My interval goes from 0 to 2 pi. So by going to 5/9 pi, I've gone all the way around here. I've gone all the way around to all 4 of these angles, but I need to continue around, okay, if I keep going. So this is just the first time around. The second time around, I would want to take my pi over 3 here, which I ended up getting not pi over 3, but pi over 9, and I'm going to add 2 pi to it. If I add 2 pi to it, then it's like I'm going all the way around the circle again, another rotation. We have to do this twice because we've got the answers for the first of the 3 tangents. I have to do it 3 times. So if I add 2 pi to pi over 9, which is really, when I add 2 pi to it, 2 pi is the same as adding probably a better way to look at it would be to, if I just go back to this location right here, instead of setting 3x equal to pi over 3, the next time around it would be setting it equal to 7/3 pi. That's the second time around my circle. So then I know that my x would equal 7/9 pi. And I can do that for each of these. All I'm doing is I'm going to add 6/3. So 3x equals 2/3 plus 6/3 would be 8/3. So divide by 3 and I'm going to have 8/9. On the next one, if I add 6/3 here to 4/3, I'm getting 10/3. So divide by 3, I'm going to have 10/9. And I got one more here. If I add 6/3 to 5/3, that's 11/3, so 11/9. These are all still part of my solutions. All right, my last time around here, I'm going to go ahead and look at adding 6/3 one more time. So 7/3 plus 6/3 now is 13/3. 13/3 divided by 3 is 13/9 pi. 8 plus 6/3 is 14/3. I'm just going to write over these. 14/3 divided by 3 is 14/9 pi. We have to make sure we're still smaller than 2 pi. Adding 6/3 to 10/3, that's 16/3. So 16/9 pi. And 11/3 it would end up being plus 6 is 17/3, which is 17/9 pi. All right, we are still within the interval of 2 pi because 2 pi would be at 18/9. So there are all of my solutions, this whole set right here, the solution to this equation. Now the reason why we had to do 3 sets is because of this 3 right here and the fact that we are restricting our interval, so I could not add pi n to my answers. All right, we've got a couple more problems left to do in this specific video here. We'll do example 8. It says use inverse functions to solve. Using inverse functions, we've got secant squared x minus 3 secant x minus 10 equals 0. Let's look at how we're going to solve that. I'm going to factor. So this would be secant x, factors of 10 to give you negative 3 would be minus 5. And secant x plus 2 equals 0. So we've got, when does secant x equal 5? And when does secant of x equal negative 2? You have to use your calculator to do this. I would rather use with cosine, so instead of using secant. So we know that from this information here that cosine of x, when does that equal 1/5? I'm just doing the reciprocal. And when does cosine of x equal negative 1/2? Well, we know the negative 1/2 part. Cosine of x equals negative 1/2 within this interval here. It happens at 2/3 pi in quadrant 2, and it also happens at 4/3 pi. All right, now for our other solutions. If I do inverse cosine in my calculator like this of 1/5, then I'm going to get, you end up getting 1.369. Let's just talk about where this would occur, okay? We know that cosine is positive here in quadrant 1 and 4. So somewhere in quadrant 1, we've got our angle that gives us the radian measure of 1.369. I also would have another one in this region here. In quadrant 4, I would have one, because that's another place where it is a positive cosine. So I need to figure out what is this angle. Well, the way that this all works is that there's symmetry. So this would be negative 1.369. So if I take 2 pi, which would be the full circle, and I subtract that value, then I'm going to get 4.914. So I'm taking 2 pi and I'm going to subtract the 1.369 and I get 4.914. All right, so that's my angle going all the way around. So I've got my two parts of 1.369 and 4.914. Then I also have it at 2/3 pi and 4/3 pi. Okay, those are all of my solutions, so this is what x can equal. And this is just for example A here. I solved my secant squared x by factoring. I used the inverses to find when cosine was going to equal 1/5 and a negative 1/2. Now the negative 1/2 comes from the unit circle, so just these angles. I had to use my calculator to find cosine of when it was equal to 1/5. That concluded that it was 1.369, but I also had to find then in quadrant 4, where would it be positive 1/5. All right, let's look at this next example, and this will conclude this video. We've got tangent squared x plus 4 tangent of x plus 4 equals 0. I'm going to factor this. It becomes tangent of x plus 2 times tangent of x plus 2. So this is asking us, when is tangent of x equal negative 2? So we're going to do inverse tangent of negative 2. This would equal negative 1.107. I'm going to go ahead and give you a sketch and show you where that would be located. Tangent is negative in quadrant 4, so we've got somewhere in quadrant 4 negative 1.107. I don't really care about where exactly, I'm just labeling it. That means we would also have one in this second quadrant. Okay, so how do I find it? Well, first I need to figure out what this location is right here as a positive angle, because I'm supposed to solve these from the interval of 0 to 2 pi. Well, at this point in time I have a negative radian answer, and I don't want a negative radian answer, I want a positive one. So I can take 2 pi and I can subtract the 1.107, and when I do that I'm going to get 6.176. So one answer is 6.176, and that answer is located right here going all the way around. 6.176. Now for me to find the one in quadrant 2, I need to just take that answer and subtract pi. So if I take 6.176 and I subtract pi, I'm going to get 3.034. There's 3.035. All right, so you're probably wondering where I got these numbers. Let me go back here. Somehow when I calculated the inverse tangent of negative 2 and then subtracted from 2 pi, I got 6.17, but that is actually a 5.17. So that's 5 here. That's going all the way around to quadrant 4, and then that would make this 2.035. So here are my solutions. I've got positive 5.176. This occurs in quadrant 4, and 2.035, which occurs in quadrant 2. Because I can't list my answer right here as negative, I can't list a negative answer, I need to go to my unit circle and figure out where are those also going to occur. So you have to work backwards and take the negative angle and make it positive. All right, but those are your solutions. This is what x can equal. All right, that concludes this video. And here is the second assignment to this work.